Okay, so 37, you have a tree casting a shadow. The angle of elevation of the sun is 28 degrees, and they want you to find the length of the shadow to round it to 2 decimal places. So here's the picture, and the function that we're going to use is tangent. So tangent of 28 equals 53 over L, opposite over adjacent. So then to solve for L, we divide 53 by tangent 28, and that gives you 99, and they want 2 decimal places, so it's going to be 99 and 68 hundredths of a foot. So you use Pythagorean theorem to solve for B. You were given A and C, and so 7 squared plus B squared is 17 squared. Solve for B, so you subtract 7 squared from both sides, so you end up with 289 minus 49, which is 240. And plug that into a calculator because they want it rounded to 2 decimal places. They don't want the exact value. So that's going to be 15.49, and they don't give you units, so that's all for B. For angle A, since you were given side A and side and hypotenuse, we're going to use sine of A. So sine of A is 7 over 17, opposite over hypotenuse, so A is inverse sine of 7 over 17. And that gives you 2432. So 2432, and don't forget it's degrees. For B, we can use, for angle B, we can just take, since we're pretty confident that we plugged in the numbers right, 7 over 17, and that the function here was right for angle A, we can just do 90 minus 2432 for angle B. So I'll just put B equals, and so that gives us 65, 68. So for angle A, you just find its complement of B. So 90 minus 32 gives you 58. So now to find side B. Well, if you're given angle B, you can use tangent of B equals B over A. So then that's tangent 32 equals B over 12. So 12 times tangent 32 equals B. So that gives you 7.50 because you have to round to 2 decimal places. For the hypotenuse, we can use adjacent over hypotenuse, so we can use cosine. Cosine of B equals adjacent over hypotenuse. So then C equals 12 over cosine 32. And that is 14.15. Okay, so for number 40, you're going to need the concept of distance equals rate times time. Right here, distance equals rate times time, because it's talking about, it's giving you a rate right here. Speed is a rate. It's asking for how many minutes. It's asking for the time. Okay, so you have the airplane that took off at an angle of 19 degrees. It ascended at an angle of 19 degrees. So the plane is going along this path. The question is, how much time is it going to take if it's going at this speed to reach 10,000 feet an altitude or a height of 10,000 feet off the ground? So we're looking for time. So I'm going to use distance equals rate times time. So I'm going to solve for time, so that I'm going to divide both sides by the rate. So this is what I need to find. I need to find the distance x and the rate. They already gave you the rate. The only problem is that they gave it to you in feet per second, and the question is how many minutes. So I went ahead and I converted it to feet per minute right here by using this conversion factor right here. Multiply those two and you get 16,320 feet per minute. So we're going to leave that aside. This is our rate. Okay, that's going to go right here. Now we have to find the distance. What's the distance from the moment it took off to the moment when it reached 10,000 feet above ground. So for that we need sine of 19 equals 10,000 over x, and then to solve for x, which is our distance, it's 10,000 divided by sine 19. So then that gives me this. Now I put dot 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 because the number goes on, right? Okay, so I kept this on the calculator because I notice it's going to be in the denominator for time. Time equals distance divided by rate. So I kept this number on the calculator, and I simply just divided by this one up here. So this is going to give me the time. The feet cancel, so this cancels with that, and then the minutes goes to the numerator because it's over minute. So remember, you do the reciprocal, so the minute goes to the top. And then this is what you get right here, 1.88, and then the unit is minute. And then you're done.